Okay, let's take a look at experiment 4. You measured the cylinder and the cube, and I use the cylinder as an example, but the calculation on the cube is similar. So many students, they are having problem with the uncertainty. So let's take a look. For example, for the cylinder, we measured the radius, height, and mass, right? So that because we measure these three values directly, so that their absolute uncertainty is half of the smallest division. So here, if you use centimeters, depends on your tool, whether you use the ruler or caliper. For example, here you have 0.05, and for the height is also 0.05, and for the mass you can have 0.0005 grams. That's half of the smallest division. And also you have your measurement. Assume that you get these values for your measurement. And for the mass. Then, based on these two values, you can calculate the relative uncertainty, which is the ratio, this one over this one, right? So you can have how about the volume? So question 1 asks you to calculate the volume. Just multiply use this equation, pi r squared times h. So this volume equals the pi times r times r squared times the h. So you can get the volume. Assume you get. How about the absolute uncertainty for the volume? Because we didn't measure the volume directly. So if we measure a value directly, that's the half of the smallest division. Because we calculate the value instead of measuring it, so we need to propagate the uncertainty of r and h to calculate the uncertainty of v. How do we do this? First, we calculate the relative uncertainty first, and then use the volume, multiply the relative uncertainty. We can get the absolute uncertainty. So, do you remember this equation? The relative uncertainty on volume equals, because the r is squared, so we have the relative uncertainty on r, relative uncertainty of r, plus the relative uncertainty on h. So that's how we calculate the relative uncertainty on the volume. Here, question 2 asks you to calculate the uncertainty of volume. So you need to calculate both the relative uncertainty and absolute uncertainty. So first, we calculate the relative uncertainty first. We assume this is 1, this is 2. So to calculate the relative uncertainty on the volume, it equals the 1 multiply 2 plus 2. So this is how we calculate the relative uncertainty for the volume. How do we calculate the absolute uncertainty of the volume? We assume that this entry is 3. So this we assume it equals 3. So use this one, multiply this one. We can get the absolute uncertainty. And for the mass, also we can, because we measure the mass directly, so that the absolute uncertainty of mass is half of the smallest division. And the relative uncertainty is this one over the measurement. How about density? So here, the density rho equals mass over volume. So we can plug in the numbers. This is approximately 3 point. How about the uncertainty for the density? Also, the density is from calculation, not from measurement. So we need to propagate the uncertainty of n and the uncertainty of v to the density. So we calculate the relative uncertainty on the density first. So use this equation. Be careful, even though this is division, the relationship is division, but we also add the relative uncertainty together. So we assume here is 4, right? So the relative uncertainty of density equals the entries in 3 plus the entries in 4. This one plus this one. So that to calculate the absolute error on density, it equals the density times the relative density. So this equals times 3 plus 4. So that's how we calculate the uncertainty of density. You need to show how you calculate the relative uncertainty and also how you calculate the absolute uncertainty.